our Masters in Industrial Catalysis is a 1 year postgraduate course based here at the University of Glasgow, where we're trying to teach you the skills you need if you want a job in industry or you want to go on and do a PhD. Catalysis is used in industry to make processes quicker and less energy demanding. So if you're looking to get on this drive for net zero and reduce the energy requirement for the chemical industry, catalysis is one of the ways that you can get there. At Glasgow, we've got 4 academics looking into heterogeneous catalysis. Also, we've got 2 ex-industrialists who come and teach on the course, and we've also got a lecturer coming up from the ISIS neutron immune source to look at large-scale characterisation techniques that are available.
In the lab scale, you manufacture, for example, a catalyst, and you're testing it in the lab. Now, there are restrictions to how much temperature you can expose the equipment to, the environment, the people that are around, and all of that. But when you get to the industry, most of the industrial plants, they run at very high temperatures, very high pressures, basically very extreme conditions. Now, the behavior of these materials in the lab under much controlled conditions will definitely be different from what you will have when you go to the industry. But if you do not understand that there is a difference when you go out there to the industry, it becomes a problem. So the aim of bringing industrial specialists here is that they give you another perspective to what you already know, what you've already observed in the lab, and then you are able to see the nuances, you're able to see the differences. You have the industrial foundation, you have the experimental foundation, you're like a hybrid entity at this point.
One of the things that differentiates a catalyst company, such as the one that I work for, and an academic lab, is our ability to be able to make catalysts at scale. There's a whole sort of science behind scale-up of catalysts. So a detailed understanding of what's important in the manufacturing process and how you apply that to larger pieces of equipment to be able to make catalysts reproducibly at a large scale.
I was secretary for many years for the Applied Catalysis Group of the Royal Society of Chemistry. And we've tended to think of fundamental research-driven catalysis that's done in universities and applied catalysis, which is basically what's done in industry. My focus has been on applied catalysis throughout my career, how to use catalytic science effectively in an industrial setting.
I found the course really, really enjoyable. I thought the staff were really helpful who I worked with. I thought my academic supervisor, who was a postgrad at the time, she was really helpful as well. And in my project, I also had the opportunity to work with neutrons as well, which isn't something you really get to work with every day in a lab. So that was really interesting.
One of our graduating students gave feedback and he really found the course helpful in getting him an industry-based job. He had skills that he needed in order to pass the interview. He was able to talk about the 2 projects he did here and the things that he learned using the techniques that we teach them. And he felt that gave him good ammunition for his interview.
One of the attractions of catalysis is it's a vast field. So you can be in it for 30 odd years, as I've been in, but you're still learning new stuff, delving into these different areas. So you never stop learning. You never get bored with the subject. There's always something new. There's always something different to challenge yourself.